have been looking at the issues of systems framework as applied to managing organizations, especially with a business engineering perspective, and as a sub concern of that analysis on systems framework, we have also tried to look at the cybernetics dimension, which throws up certain methods, techniques, approaches to calibrating organizations, to keeping them on path, giving them a goal directed behavior, and generally keep the operational model of the organization under control. However, to complete the discussion on the systems framework, which somehow gives the impression that the world is a very orderly experience, everything is systematic in terms of its own internal operations, in terms of its relationship with others, and the processes are predictable, therefore malleable to intervention, and generally a notion that you can design a system which is perfect and therefore orderly and therefore amenable to managerial interventions. Let me assure you, this is one of the fond fantasies of a lot of management experts, which has limited correlation to the actual realities of work situation. The actual management of organizations is as often open to vagaries of attitudes, noblest of human emotions, the vilest of human emotions, ego trips, pure and simple unmitigated viciousness, ego trips, a desperate desire to rise to the top without really putting it in a comparative frame on whether you deserve to be at the top or not, and at the same time the ability to help others, the ability to be supportive, the ability to work for institutional interests, the ability to recognize that individual cannot prosper unless the organization prospers. So, it is quite a potpourri. It is very difficult to create a systems framework around emotions. It is even more difficult to create a systems framework on predictive validity of human behavior. But that does not mean that systems framework does not exist. The same system framework exists, and it is very much a reality in terms of certain dimensions of organizational life. But between the systems orderliness and the vagaries of human emotions and human foibles is what could be called the contingency situation. The contingency theory states that there is no one best way to manage an organization, because what works for one organization may not work for another. Situational characteristic contingencies differ, and this is the big catch. After you have just about solved all the world problems with the systems perspective and taken a position that yes, intervention is possible and it is possible to lead everyone up to the path of salvation and heaven, you suddenly discover that there is a factor which was not accounted for when the planning processes took place, and there is a factor which is a sudden eruption of some undiagnosed dimension which has to be handled. So, for want of a better phrase, this has been called situational element. The situational element has been often confused with what happens in a situation, but it is not a question of what happens with a situation, it is a question of what happens unprogrammed. It is a question of what happens all of a sudden. So, the word situation, like many other words common to management discipline, has a specific meaning in the subject area. To handle this has there been a need to theorize, and that theory has been called contingency theory. Now, contingency is a word which derives its connotation from the word contingent. The word contingent has a meaning, we need not get into all those niceties here, but operationally it means that which happened all of a sudden, that which was not predicted. It is like an accident, and even if it is not an accident, it is an eventuality, it is a sudden experience, very often unexplained. So, managers need to understand the key contingencies that determine most effective management practices in a given situation. Some of you may have read the book The Hinge Factor, which is a classical elaboration of how the chance events shaped history. The Spanish Armada approached the British shores, I am talking of the medieval period, and the Spaniards were all set to invade Britain. Britain was practically defenseless, and the mighty armada, and there was not another armada like this in the world of those times, was just off the shores in the Bay of Biscay, ready to attack at the strike of dawn, and during the night the storms came, the winds blew, lightning struck, and there was a huge tornado. The entire Spanish armada was dispersed, and the British historian writes, and God blew it away. Now, this is not something which could have been put in naval history as programmed. Naval experts could not have planned a typhoon, a tornado, lightning, winds blowing of a power which drives away an entire navy, not only in terms of putting it away, but in terms of knocking it out of commission, a contingent situation. One of the battles of Panipat, Hemo was leading the Indian contingent and was about to clinch victory, when a stray arrow came and struck him in the eye. The pain of an arrow striking an eye can be well imagined. He put his hand to the eyes, and his elephant went out of control because Hemo was more busy attending to the arrow which had struck him. The Mahawat, the person driving the elephant, was equally disturbed. He started attending to Hemo, and the elephant turned and went into a sprint. The army saw that Hemo had turned around, because they saw Hemo's elephant turn around and run. They thought that Hemo, for reasons best known to him, had decided to beat a retreat. So, they all, while winning the battle, turned around and followed Hemo. And the historian goes on to record, a chance factor decided the day, and the Indians lost the battle of Panipat to the invaders. The Hinge Factor is a book worth reading. It helps to bring a lot of sobriety to experiences of life, and contingency theory brings to the manager a lot of sobriety to know, no matter how well you are prepared, you still may have situations which you have to bat as you come along. Therefore, in many ways this is the opposite of an approach which systems theory propagates. So, very often while talking of systems theory, people also refer to the contingency theory. The managers, as I was trying to explain to you, need to understand that the key contingency that determine the most effective management practices in a given situation may vary. That brings us to the study of cybernetics, and we will try to understand the application of cybernetic principles to organization management and see to what extent it contributes to making up a sound framework of managerial action. Cybernetics is the interdisciplinary study of the structure of regulatory systems. This, I think, is a pithy definition of cybernetics and serves the purpose which we have in mind. The focus here is on regulatory systems and the perspective is on structure. Each organization has some regulatory system, and as we go through experiences of running organizations, we find that there are regulatory systems endogenous to the organization and there are regulatory systems exogenous to the organization. For example, to get to the illustration of the telecom industry, there are regulatory systems, say in a telecom firm, which comes out of the policy and strategy outlined by the board, and there are regulatory systems which come out of the Telephone Regulatory Authority of India or the Telecom Regulatory Authority of India, to put it more precisely and as it should be captured. Be that as it may, cybernetics is an attempt to read patterns, to create a situation which is amenable to scientific thinking. Cybernetics is closely related to control theory and to systems theory, that you can clearly see is a derivation from what I have already been explaining. Cybernetics does not ask what is this thing, but what does it do and what can it do. This is a very important distinction to keep in mind while trying to understand the nature of cybernetics. Cybernetics does not get into fundamentalist dilemma. What is this thing? How was it created? No, that is not the business of cybernetics. The business of cybernetics is what does it do? It is an action discipline, and if you ask what can it do, it also has to explain what can it do. Once you have got that perspective right, then it is about time we recalled some of the major contributors to the growth of cybernetics theory, and there was one mathematician, at least one neurophysiologist and one academic by profession in terms of being a teacher, and they all helped to create the present disciplinary knowledge which is labeled cybernetics. The mathematician was Norbert Wiener, the neurophysiologist Warren McLeod. Now, you need neurophysiologists to understand the laws of nature, to know how orderly nature can be and try to replicate some of that order in human behavior. And of course, J. Forrester is a name which is often referred to, very little to do with the actual appreciation of his readings and writings, but then these are names which are almost buzzwords and have been bandied around hugely. Cybernetics can be defined as the study of interaction between man and machine and animals. I do not want to dwell too much upon the business of interaction between man and machine, because we will be coming up with this treatment of the subject matter later on. Man machine has several dimensions which needs to be understood in a holistic frame, and not just that of cybernetics, but it is a question of finding one's way around it. Cybernetics operates on two levels: the study of an observed system and the study of the people studying a system. Now, this is a very important distinction. The study of an observed system has to do with structure processes, and it has to do with the predictable, the malleable, the manageable, the controllable, and you can find as many synonyms of orderliness of an operational organizational system. The other part of cybernetics is the study of the people who study a system. Now, that is an interesting component to which we shall pay some attention in course of time. It originated from the R&D process in development of the atomic bomb and applied scientific theory and principles in real world setting. So, cybernetics is a relatively youngish approach, a relatively newer subsystem of systems analysis, systems dynamics and systems theory, but it has been found to be extremely useful, and there are many people who would want to swear by it. The examples of cybernetics are many in actual life. The easiest which comes to mind is the air conditioner. The air conditioner responds via thermostatic control to changes in temperature for the purposes of maintaining a reasonably constant temperature at its place of installation. It can be home, it can be office, it can be anywhere, but all air conditioners are known to be calibrated to a given degree of temperature, which means that following the principles of thermodynamics, the control system switches off and thermostats makes it one where it will not cross say 24 degrees if the temperature is calibrated to 24 degrees. Similarly, the cooling system will be triggered off if the thermostat gives the command that look, the actual room temperature has fallen below 24 degrees, it needs to be restored to 24 degrees. So, the principle is keep the temperature at a given point. If it goes above, reduce it, if it goes down, raise it, and that makes it necessary that the principle of thermostat be understood to see how air conditioners work. Apply that to organizations. If systems entropy in terms of operational parameters goes beyond a point, then we need to call for a rejuvenation, a revamping, which can be in the form of restructuring, redesign, relook at the information flows and the works. If, however, there is an over control, there can be a command arising out of an analysis of how relaxing control may actually get better results in the organization. In the automobile industry, the automatic cruise control can also be considered an example of cybernetics. The automatic gear system is symbolic of what cybernetics can do to machine systems and how it actually operates. With these examples of cybernetics, it is easy to get into an understanding of the scope of cybernetics. Go through this slide. I suppose you will find the description interesting. You would have hardly believed when you started listening to these presentations that at some stage psychology, cognitive science, epistemology, postmodernism, constructivism, science will all be put together. Well, now you know that it can be put together. You may have picked up a new word or two in the course of this narration. For example, limits of knowing is epistemology. Not everything can be grasped. Yes, and it is a very important concept to have in the era of knowledge management. Hearer and makes the meaning is an essential ingredient of postmodernism. It is not what you intend that is important, it is what the listener understands that is important. So, if that, to recap, is the scope of cybernetics, then what are the key applications of cybernetics? The key applications predictably will be theoretical and the key applications will be practical. Theoretically, sciences of complexity, including artificial intelligence, neural networks, dynamically oriented systems, yes, even chaos and complex adaptive systems are the theoretical applications of cybernetics. Now, that is really pitching it at a level which would grasp the interest of some, because anything which has to do with artificial intelligence, neural networks, dynamical systems, and in fact, even chaos, why overlook the complex adaptive systems, is considered highbrow, is considered at the cutting edge, and it evokes a lot of interest, perhaps rightly so. But then the danger is all these components of the cognitive domain may get so emphasized that the other more routine, but equally central characteristics are lost. Because remember, it is not only necessary to keep innovating, which is again important, but it is equally important to keep the routine going. But how often does one hear of paying attention to the routine and doing it thoroughly? But innovation is a chant. Everyone claims to be innovative, everyone demands innovation. It has been sloganized so much in the last 20 years that, like many words, it has lost its meaning, or perhaps that can be sobered down a little to say it has almost lost its meaning. Then there is the practical application of cybernetics. Many of the concepts used by system scientists come from the closely related approach of cybernetics, such as information, control, feedback, communication. Now, these are areas which are more conventional, with which people are more familiar and people practice it more. Now, everyone has heard of feedback, even those who are not in the domain of psychology or who are not in the domain of scientific analysis or who are not in the domain of management. Yes, know the word feedback and know the utility of it. So, also about communication, much used. So, the practical applications of cybernetics are more widely known. The theoretical aspects of cybernetics are less widely known, but are certainly more fashionable. Be that as it may, it is important to realize that applications of cybernetics are wide and are very, very effective in certain areas of management. There was also a return from the machine to the living organism, which accelerated progress in neurology, perception, the mechanism of vision. It was a result of the cybernetics approach. Because of cybernetics, people realized that the logic of machine does not apply, cannot apply, and very often confuses the man machine relationship, and the man element very often is the key element in contributing to a decision frame. This obviously had its impact on neurological aspects, the perception studies, and of course, certain physical analysis. In 1960s, MIT saw the extension of cybernetics and systems theory to industry, society, and ecology, and from that point of time, management theorists, management practitioners began to be curious about application of cybernetics to management, and it has made a definite place for itself in management theory and management practice. Fundamental concepts of cybernetics are enormously useful in a variety of disciplines such as computer science, management, we have already talked about that, biology, we have talked about that, and even sociology. Understanding of sociology is to a great extent facilitated from the cybernetics perspective, because it facilitates the practice of social engineering. The predictive validity may not be as of such a high level of confidence as it would be in physical sciences, but still it is better than having no predictive validity. Cybernetics and system science combine the abstraction of philosophy and mathematics with the concreteness of dealing with theory and modeling of the real world evolving systems. Now, that is a very important concept. I would like to repeat that for you, so that you get all the nuances. Cybernetics and system science taken together combine the abstraction of philosophy and mathematics with the concreteness of dealing with the theory and modeling of the real world evolving systems. So, cybernetics fulfills a very useful role in serving as a bridge between the abstract, the intangible, but important component of real life with the specific and the real world elements of the concrete, the specific things which make an impact. Cybernetics and system science experts are trained in a traditional speciality, and that speciality may be from a conventional discipline. Once they learn the principles there, they apply it to other areas, from the study of structures, design, and indeed processes. One gets a clear feeling that a lot of principles of biology or botany or plant life, when applied to organization theory and practice and the functioning of organizations, are extremely edifying and help to see a pattern or meaning which prima facie seemed elusive and difficult to grasp. Thus, their exposure to cybernetics and system sciences helps a management practitioner to be more scientifically ad hoc. Now, that is not a contradiction in terms, because I have spent some time explaining to you how ad hoc situations have to be met. But when you go scientifically ad hoc, it means that you have been trained into dealing with the unexpected, you have been drilled into n number of models, and those models have given to your cognitive system a resilience to respond quicker to ad hoc situations. Therefore, ad hoc situations, and specific to the two approaches, would be the fields where they apply themselves and how you actually operate as a theoretician in the field of organization management, or indeed even finance or marketing. There are certain laws of cybernetics which I would like you to grasp, because ultimately if cybernetics has to do with creating systems, if cybernetics has to do with creating practices, if scientific has to do with certain regulatory mechanisms, then clearly there must be certain laws. So, I will pause there for you to read this slide. As you notice, the attempt is made to pick up laws from different places and postulate them in decision making and problem solving. Take for example, the second law of thermodynamics. In any closed system, the amount of order can never increase, only decrease over time. Very interesting theory, seen very often when it comes to maintenance, seen very common when somebody takes over in authority, always begins with pleading for discipline, control, systematization, almost cleansing what the person believes is the residue of bad decisions of the preceding period. Then as time passes, the chant slightly reduces in pitch, the reality perception dawns, and the person learns to adjust with the way the organization has been functioning. Now, how that equation resolves itself is a matter of organizational vitality, individual temperament, circumstances, and we are not going to get into that. But the larger principle is, the second law of thermodynamics says that order tends to decrease rather than increase. Therefore, the randomness of a situation gets priority, and that is a very interesting thought. I would have almost said that is a very worrying thought. But whether one is enthusiastic about it or worried about it, it cannot be made a factor of wishfulness. The second law of thermodynamics, therefore, is a very important framework of reference for organizations. Then there is the complementary law. Any two different perspectives or models about a system will reveal truths regarding that system that are neither entirely independent nor entirely compatible, underscoring a reality of life. Much of human life is bounded in contradictions. Oscar Wilde is a great example of capturing those contradictions. There is a quotation from Oscar Wilde, some of you may relate to it. For everyone kills the thing he loves. When I first came across this statement, my reaction was of surprise, on thought converted to horror, because I could not understand how love and violence of this type could coexist. And then gradually, as I went through Oscar Wilde's elaboration of the things and the elements in the two emotions, it dawned upon me that you can love so well that you make it claustrophobic for the other person, or you can love so well that you take it for granted. You love so well that you start demanding total congruence of lifestyle. And there are a whole lot of possibilities where love, instead of nourishing, can become very, very inhibiting for the people who are involved in it. If that was not so, there would be no narrations of how a man and a woman can meet, get into an emotional relationship, get in love, and then the predictable parting takes place and it ends it ends in divorce. Not all love stories go that way, but the fact is Oscar Wilde felt that the negative elements in love were very dominant. Be that as it may, that illustration is brought up to explain that systems will reveal truths regarding the system that we neither entirely that systems that are neither entirely independent nor entirely compatible. There are other examples. One can have a love-hate relationship, but suffice it to say that the complementary law is essential in terms of applying it to organization theory from the cybernetics perspective. There is the law of requisite variety. Control can be obtained only if the variety of the controller is at least as great as the variety of the situation to be controlled. In other words, if the situation to be controlled is a hugely complex one, then the person in command has to be equally multidimensional to be able to operate it. It seems to me therefore, that control is a very active force which has to be intelligently applied to have cybernetics overtones. The law of requisite hierarchy is equally important. The weaker and the more uncertain the regulatory capability, please note the weaker and more uncertain the regulatory capability, the more hierarchy is needed in organization of regulation and control to get the same results. Again, a very interesting proposition which establishes that if you are not a Zeus, if you are not a strong leader, if you are not a person who lays down the laws, then you need a more extended hierarchy for the regulatory operation to be effective. At each stage, you take out some of the force of deviation. The general principles of cybernetics can be listed as the following. Please read it. Well, the way I see it, there is nothing very complicated in any of these four statements. If you are a person of experience, you would resonate with all of them to some degree. And I personally do not think it is necessary to go through it, other than to point out that the system holism principle is a system which is central to the study and application of systems theory. If a system has holistic properties, then those holistic properties may not be available in parts in suitable fractions. Yes, please note that. If a system has certain properties, the holistic property may not be available in all the parts in certain fractions in ratio to the size of the part with the whole. Similarly, the parts may have properties which are not manifested in the system as a whole, and we have discussed this earlier on. The suboptimization principle is that if subsystems tend to go on their own, then the whole system will not be as efficient as it could. Very simple to understand. And of course, everyone knows that no system can be known completely. Everyone knows that about human beings, or at least everyone should know it about human beings. No human being can be understood fully. There are always layers which are unknown, very often to the person himself. But here the reference is to the nature of organizations. And what is being said is, it is very difficult to know the nature of any organization fully. And of course, the 20-80 principle or the 80-20 principle, whichever you choose to produce first, is a truism which is there available in everyday language. So, one need to dwell upon it. There are certain other principles to which I would like to draw your attention. The basics of the stability principle, that is, the complex system have basis of stability separated by thresholds of instability. Please note this, the complex systems have basics of stability separated by thresholds of instability. A system dwelling on a ridge will suddenly return to the state in a basin. Amusing, but can be true. Viability principle. Viability is a function of the proper balance between autonomy of the subsystem and the integration within the whole system, or of the balance between stability and adaptation. In the Indian philosophy, this would be labeled as the middle path. One has to be clear that there has to be forever a balance between polarities, and that is how the system works. The first cybernetic control principle, successful implicit control must be a continuous and automatic comparison of behavioral characteristics against a standard. Now, that is something which needs to be understood. Successful implicit control must be a continuous and automatic comparison of behavioral characteristics against a standard. It must be followed by continuous and automatic feedback of corrective action. In other words, you must be forever be in a growing mode, you must be forever be in a mode which leads to improvement, otherwise decay and decline will set in, or to convert it into a modern parlance, it takes a lot of running to stay at the same place. The elaborations continue, and I present to you another set of 4 principles. Second, cybernetic control principle. In implicit control, control is synonymous with communication. Nothing much to explain, but plenty to understand. In implicit control, if you want to control in an implicit manner, control is synonymous with communication, which is why nothing is so terrible to operating organizations than breakdown of communication between departments, among entities, among people. If you keep talking, then it is better to expect results than if you do not talk. The implicit control is, as we have defined control always in the discussion, keeping the system on track, and implicit means every action leads there. The third cybernetic control principle is in implicit control, variables are brought back into control in the act of and by the act of going out of control. Read that carefully and you will find that it is not such a twister. In implicit control, variables are brought back into control in the act of and by the act of going out of control. This means there are limits by which things can get out of control, and it will ultimately get back into control. The feedback principle, the results of behavior is always scanned, and its success or failure modifies future behavior. Very important principle to learn. The result of behavior is always scanned and its success or failure modifies future behavior. Of course, there are certain people who will never learn, but they are the exceptions, they cannot be made the rule. The maximum power principle, those systems that survive in competition between alternative choices are those that develop more power inflow and use it to meet the needs of survival. Well worth remembering for any manager for effectiveness. To conclude, therefore, the principle remains that comes to mind is hierarchy principle. Complex natural phenomena are organized in hierarchies, wherein each level is made up of several integrated systems. Redundancy or resources principle. Maintenance of stability under conditions of disturbance requires redundancy of critical resources. Redundancy of political command principle. In any complex decision network, the potential is to act effectively, and this is conferred by an adequate consternation of information. Relaxation time principle. System stability is possible only if the system's relaxation time is shorter than the mean time between disturbances. This is indeed a derivation of the cybernetic principle, but very important in operating organizations. And finally, the negative feedback casualty principle. Given negative feedback, a system's equilibrium state is invariant over a wide range of initial conditions. I hope you will see the applications of cybernetics more clearly to management, especially as it is a strong extension of systems theory, which leads to a situation where positive feedback and the casualty principle goes together. The homostasis principle operates. Steady state principle is borrowed from management to understand organizations, and self organizing systems principle dominate. Again, some time to you to read the applications of systems theory in its cybernetic incarnation to running of organizations. You would be familiar with some of them. It is the application that you have to note. The last two principles have the greatest application to management. Steady state principle, where equilibrium of the subsystems is put out as a desirable condition for the equilibrium of the system itself, and self organizing system, where complex systems organize themselves and their characteristics in structural and behavior patterns, which results because of interaction between the subsystems. There is a lot of wisdom to it in operational terms. And that brings us to a close of the discussion of the application of systems principles and cybernetics models to decision making, problem solving, in the functioning of organization and in the operation of human resources in work environment. Thank you.